Today you will find the expected value of means and variance of probability models. First thing we're going to do is we're going to look at the example of the money duck. So what you can do is you can go to this link and watch this quick video to explain what the money duck is. Okay, so what price would you pay for the money duck? Notice we have different distributions. Remember, in the duck itself, there's either a dollar bill, a $5 bill, a $10 bill, a $20 bill, or a $50 bill. So which do you think seems reasonable? Okay, so notice the histogram off to the right. This is what we call a probability distribution. Okay, so what does it tell us? Well, this probability distribution tells the possible events for the money duck and the likelihood of each event. So if you're selling money ducks for $5, why are each of these distributions bad for business? Okay, so why would the first one be bad? Okay, and then why would the second one be bad? Well, hopefully you're thinking in your mind, the first one is bad because people will give up and stop buying the duck because they recognize that there's only a dollar bill. B is bad because a lot of $50 bills will be given away for only $5, so the business really isn't making any money. Okay, so let's talk about what a random variable is. A random variable assumes a value based on the outcome of a random event. Notice we use a capital letter like X to denote a random variable, and the value of a random variable will be denoted with the corresponding lowercase variable. There are actually two types of random variables. A discrete random variable can take one of a countable number of distinct outcomes. So today we'll be looking at discrete random variables, and we will in the next lesson as well. Continuous random variables can take on any numeric value within a range of values. So notice you have two pictures down at the bottom of your sheet. The basketball picture is more than likely a discrete variable because the number of shots the player takes is countable number of distinct outcomes. Whereas the picture on the left with the lady studying, that could be continuous because the amount of time she spends studying can be any range of values. So if you recall from Unit 4, Part 1, the expected value of a discrete random variable can be found by summing the products of each possible value by the probability that occurs. So this formula in right here is actually on your yellow formula packet. So you're going to take the sum of the outcomes times their probability. Note to self, be sure that every possible outcome is included in the sum and verify that you have a valid probability model to start with. So if we look at our first example, we're going to practice finding the expected value of the money duck. Let's look at the first histogram on the left. So to set up this expected value, notice we take the value times its probability. So 1 times 0.5, 5 times 0.2, 10 times 0.1, 20 times 0.2, and 50 times 0. What you're going to do next is you're just going to type all these values into the calculator exactly like you see. Hopefully you find an expected value for this first one of $6.50. Let's move on to the middle histogram and find its expected value. Okay, so notice we took 0.1 times 1, 0.1 times 5, 0.1 times 10, 0.2 times 20, and 0.5 times 50. And then we type it just like we see in a calculator. Hopefully you find an expected value this time of $30.60. Now let's find the expected value of the third histogram. So notice for our expected value, we took the outcome, $1, times its probability, plus the 5 times 0.1, plus 10 times its probability, plus 20 times its probability, plus 50 times 0.35, and hopefully you find an expected value of about $28.25. So from a customer standpoint, which distribution would you prefer? Well, if it were me, I would prefer the middle one because it has the greatest expected value. From a business standpoint, which one would you prefer? I would probably say the $6.50 one. Let's look at another problem. So, notice we have one of the authors took his minivan in for repair recently because the air conditioner was cutting out intermittently. The mechanic identified the problem as dirt in the control unit. He said that about 75% of such cases, drawing down and then recharging the coolant a couple of times cleans up the problem and costs $60. If that fails, then the control unit must be replaced at an additional cost of $100 for parts and $40 for labor. In letter A, it says we're going to define the random variable and construct a probability model. So obviously we're talking about a repair cost. So I'm going to say X equals repair cost. The next thing we'll do is we'll construct a probability model. Okay. When I write the probability model, I like to set up a similar table. So notice we have a couple of components here. We have the outcomes, which we can recharge, right? The story says drawing down and then recharging the coolant a few times clears up the problem. Or we have the replacing. Notice we have what the result of that outcome is, and we have its probability. So for recharging the coolant, we know that it cost $60. And it clears it up 75% of the time. For replacing the coolant, you have to pay the $60 initial dollars, the $100 for parts, and the $40 for labor. So the cost for replacement is $200. And the probability of that occurring is the complement of just recharging. So this would be 0.25. And there is our probability model. If we look at letter B, it's saying what is the expected value of the cost of this repair? Okay, so remember you're going to take the recharging cost times its probability plus the replacing cost times that probability. And it should give you an expected cost of about $95. Notice in letter C it says, what does this mean in context? Okay, so with this expected value of $95, it just means that vehicle owners with this problem with the air conditioner can expect to spend on average about $95 to fix it. Now let's talk about standard deviation. Okay, so for data, we calculated the standard deviation by first computing the standard deviation from mean and squaring it. Okay, we do that with discrete random variables as well. So our variance. Now, if you have forgotten what variance means, remember it is just standard deviation squared. Okay. Remember, variance is another form of spread. It is the standard deviation squared, and we like it because it makes the math easier. Okay, so notice that we have our formula. The variance formula, I believe, is on your formula packet. Notice we're going to take our x values minus the expected value, square it, and then times it by the probability. And then we will add all those up in the end. Remember, to find the standard deviation from the variance, you would square root whatever you get for the variance. Okay, so we had an insurance example when we did expected value in Unit 4, Part 1. So recall that, notice we have our outcomes, we have our probabilities, and notice we already have our differences here. Okay, so it's going to make our formula that much easier to compute. So I always start these with sigma squared. Okay, so when you square root your variance, you have your standard deviation. Let's look at another one. Remember we had a restaurant and it was Valentine's Day, and people, if they drew the Ace of Hearts, they would get a specific discount. Okay, so remember the expected value we found for that specific discount was $5.83. So notice that we had our 20 minus the expected value times its probability here. We had 10 minus the expected value times its probability squared here. And we had 0 minus 5.83 times the probability 2/3. And don't forget to square the 0 minus 5.83. So now you can type this in exactly like you see in a calculator. Now, if you're really handy with using the list function, you can do that option as well. So hopefully you found your variance to be $74.34. And remember, the final thing that you have to do is you have to square root that number to get the standard deviation. And we do get about $8.62. Okay, you are ready to do the practice that says expected value part 2. And if you wanted an extension to the money duck, notice, given this is the price, decide on a distribution that would give you $3 in the long run.